Let's give it a few minutes for everybody to try to get in. I'm not sure anybody's catching the Saturday stream. Hey, so guess people are here, just waiting around to see who's going to show up, and I will start talking about the the updates. That makes three. See who else is going to show up. Give it another minute or two. I guess I could chit chat while. Sorry. I guess I could chit chat while I wait for people to show up. Um, so I was. Let's see what happened this week. I ordered some more PEI from Shane. I guess he was helping me out a lot on the chat. Um, Ended up getting a few sheets because I need to replace those seatbelt sheets anyway. And the two that I ordered like a few weeks ago didn't get shipped, so it was kind of weird. So I decided to reach out to him on chat and see what's going on, and he was able to figure it out and add a few more sheets to the order. So they get a few sheets shipped at the same time, which saved me some shipping, and so it's good so far. Um, let's see. I guess I could talk about the. I'll start right into it. I mean, people could review the stream later, but basically, we made some progress last week. So like this week, I should say, on the XY characters. So um, after some playing around and suggestion from you guys, I changed some of the dimension of some of these, some of the parts like the tensioner here. So I added some beef here between at the end of the belt and the start of the tensioner. Um, Added some meat down here so it is um, it's a little bit stronger. And I had to change the profile of the belt here because after printing it out, it was very very tight fit. It was hard to um, get the belt in there. So what I did is I added about half a millimeter into the channel so that the belt could fit a little bit easier. Lengthened the block so that it took up more space uh, inside the cavity here. So basically, what this gives us is almost let's just get a dimension here. 5.5 millimeter, right? Is that what it says? No, 6.5. So it gives us 6.5 millimeters of adjustability. Each teeth on the GT2 belt is 4, so that gives us each teeth is 2, but the distance between the two teeth is 4, I should say. So that gives us 2.5 teeth of adjustability. So the from looking at it, because I'll show you guys this later. I printed it out, and the adjustability works out really nicely. I think that's about all we need is about 2 or 3 teeth um, a worth of adjustment there. So the amount of teeth that's on this side is 9 tooth and 8 tooth on this side is enough to grip the belt really tightly, and then the adjustability allows us to get the correct tension on the belt. So I got the printed uh, first article, I guess, here, and you can see that like uh, there's quite a bit of space in here for adjustability, and all you really need to do is basically like adjust that all the way in for more tension, and then you can back it out for less tension. So normally the when you back it out, the belt would give a little bit of spring tension, so pull it back out so you don't have to push on it. And the nice thing about this is that the 3M bolt is long enough to go through the nut trap to the other side, so it guides it in a straight fashion. And once you have the other half, which is this is the front half of the carriage. Once you have that, it traps it in there, and it's pretty sturdy. There's not enough wiggle room in there, so once this all assembled, the tension works really well. The tensioner works really well, and after I printed it out, I mean, looking at it on the screen, it looked like the belt width was gonna work, but looking like now that I play around with it, um, this is really tight. I mean, I'm yanking on it with all the forces that are coming out. After playing around with it, finally got the right channel grooveness, like the groove thickness here. So this is pretty much final. The only issue that's left to kind of solve is and to double check is I ordered the I guess rotating bushings in here, so I had to check to make sure that the it's gonna fit in the groove here just fine. That's one thing. The other one is um, I'm having little problems with the countersink here and the nut trap on this side is because the print orientation is flat on the bed, and because the most of the detail work here is on the top, the support material is pretty hard to get off the holes. So I've been playing around with an idea of built-in supports, and it just kind of giving me a little issue because the clearance, you have to make it large enough to support that hole, but small enough or have enough offset so that it's easy to pop out. So it's giving me a little issue. I gotta play around with that. So it's not a major showstopper, but it's hard to it's a little more trial and error. Then the big rod hole in here, that support is not really working all that well, so I got to play around with that as well. The the hex nut traps on this side is horrible. I mean, I can't get it working correctly. So again, that I'm debating whether we need these nut traps, because what's happening is that this is actually going to be facing away from the print envelope. So having nuts exposed on the outside on this side is not going to cause a big issue. So if worst comes to worst, I'll just leave the nuts on the outside of the case. Just not doesn't look as nice as the nut traps. Or the other option is to use those melt-in thread holders in here. So like I said, it's one of those situations where it really it's not a showstopper. It's just aesthetics, right? The other thing is, if I can find it, I did get some sample ones last time, but they're not the right size. I got to get the right size. But the idea is that they would go in there. That thing's out of the way, and it would give you a smooth interface to the rod. So there's a little bit of play, because this one is not this rod is the ones that came with the machine. It's not really that great, but it slides pretty well. So the idea is that the once I get it in there, is gonna hold it and allow it to slightly spin and correct for any misalignment issues. So for now, I'm considering the XY carriage blocks. They're pretty much done at this point into what do you call it? Sorry, I consider them done into I get the bushings to test the fitment, and then the bushing here to test the fitment on this hole. Into then, I'm not gonna work on this anymore. It looks really good the way it is, and um, there's not much more shaving of the inside or anything like that I could pretty much do. So it's as small as I'm gonna be able to get it, and it seems to work. They're pretty lightweight, so there's not gonna be a lot of weight on the gantry once it starts moving. So that is pretty much done. So happy with that. So we will need 4 of those for 4. I'll show you guys in the picture, but we need 4 of those for the 4 XY carriages. So I started working on the motor mount, and I thought it did pretty good. I mean, I did this morning, and I'll bring up the picture of it. So I showed you that already. Showed you that. So that's the motor mount. So the here's the second thing second part we have successfully printed that we designed on the for the printer. So the side braces I designed so that the I know this is not the right size, but you get the idea. Is it will clear the belt. So this is a really big one, but it will clear the belt with the way the side braces are on either side. So the way that the motor mount had to work was, on one side the belt comes off this way, on the other side comes off this way. So I didn't want to build 2 separate parts, and I didn't want to have to print a mirror image of a square brace on one side and a rounded one on the other. This is pretty solid. I mean, I'm the base is 5 mil. Here's 8 mil thick where it bolts to the extrusion, so it's not going anywhere, and it's got two M6 mounts to go on the extrusion, so it's not. I think it's pretty much done. I mean, I guess that's what I'm gonna say is it's not bad for like this morning. I worked on it this morning, and it's pretty much done until I run into issues with it. The so one thing about this one is I have to still work on the alignment blocks. So I haven't done the alignment blocks yet, I'm debating whether I even need them because it was printing pretty nicely, and if I did an alignment block here, I had to kind of add support. I'm just kind of lazy, so I'll leave those for now until I figure out where I need them, or whether I need them or not, and I'll add them later. I like alignment blocks mainly because it makes it easier to kind of slot slot them in into the right spot on the extrusion. But the thing is that once you have it in there, right, is sometimes it's hard because if you make it exactly 8 millimeter, your printer might not print exactly 8 millimeter, maybe a little off, so it makes sliding around harder. Sliding is important on this part because what this also serves as is the tensioner for the pulley. You would slide this up and down the extrusion to tension the belt, the drive belt. So I'll show you guys that in a minute. But this is important to be able to slide. So I might just make that alignment block like 7.8, and then we could go from there. Yeah, this is pretty much hawk proof. I mean, like I'm like really like pulling on it and stuff like that, and it's pretty sturdy. There's not a lot of flex on it, which is important as well. So I think I'm happy with this part. So again, it's good progress. The second part of the printer kind of just I'm like having the extra one each bolt extended not issues to make it more proof. Oh, you mean like these holes? You want an extra 1 mil extended into the extrusion? Um, yeah, I can see what could like if that's what you mean, Steve. I will see like maybe you could tell me what you mean later, and then I could try to make that. Um, yeah, maybe that would work because I guess what I could do is I can make this whole thing. Yeah, the nut sits against the plastic sits against the seat. Yeah, I'll try that. Maybe that's a good idea for any of the parts since I'm doing all of them anyway. I'll keep that in mind. Thanks for the suggestion. So again, so happy with that. Second part kind of done. Then I went back and spent some time on the layout. I mean, you can tell this is pretty damn complicated. It's getting a little complicated as is. So let me kind of walk through what's happening in this diagram because it's kind of complex. So um, that's the motor mount that you guys were looking at before, and what that is um, it slides along this channel here, up and down. That will provide tension between this pulley and this pulley here. If you go down towards the pulley for less tension and up away for more tension, right? So that that that's going to be a closed loop belt between here and here, a very small one. I'll show you guys a picture of it later. That's going to go from here to here to turn this axle. So the so the corner here actually had to go with a double wide, like a 3060 here, to give mounting for this guy onto this extrusion here. Because one of the so let me kind of explain why we had to do a double width extrusion here. Because remember, one of the first rules or design principles we had was keeping this and this channel clear so that you guys could slide in side panels to enclose the printer. Normally, that motor mount would have went down here into the extrusion, and then we would have moved these axles closer, and then the belt would have been just right here. But because I this is kind of off limits, this and this is kind of off limits to me, I had to kind of go with a double wide to give me something to mount this onto. So that is the reason why we went with a double wide here. I mean, I didn't even adjust this yet, but you kind of get the idea. So that one is there for that. And the other thing is that to make this more compact, we did away with the other. I think last week you guys saw I was using different. Let me bring that up. Last week I think we were using a different holder, so I think we're using this one. Bring this up. We're using this one for for the pillow block. But what I found was that it was taking way too much room. I was leaving a lot of space to that design there. So this is the third part that's being designed right now. Is zoom in a way you guys can see that. So basically, it's just gonna hold another one of those flange bushings against the extrusion to save on space. I mean, the footprint of this is way smaller, so it gives us more space for this pulley here, because I had to make that pulley work for this space, like within this envelope. So it's kind of tough. I had to make that choice to kind of do away with that. So I'm kind of going all over the place here. Let me show you. Let me see if I can get a good angle of the other one. So this is the other one. So here's the problem. Because I'm using a double wide, this one no longer has, like, this bolt hole. Let me see if I can highlight that hole. Well, you guys can see I pointed. This bolt hole here is going to be directly on this metal part, so that's not going to work. So for this special corner, I have to sort of extend this part to use this channel, which I would do in the afternoon. So that way it will keep it in the same spot, but one bolt will go through the horizontal and one bolt will go through the vertical. That's going to be needed only for the corners that have motors on it. The other corners could use the regular one. So you see we have the same problem here where I haven't replaced this yet, but you see I have the same problem where I have one hole in the horizontal and one hole in the vertical. It won't work, so I have to kind of like, I have to extend. I would have to use that same part here to extend it to the vertical here. Again, double wide here because I needed this motor mount to drive this pulley. So you can see this motor drives this and this rod. This pulley drives this and the one across the way. So that pretty much solves the drivetrain issue. It's slowly coming together. I was still working on this. I needed to use that low profile bushing mount here and here so that it completes the drivetrain. I looked at this and I was able to use two. I had enough space for two singles, because I think that was one of the things I talked about in the last stream was the difficulty of getting a double here to work. So it doesn't mean that we have to stick with this if we found a double, or if we wanted to print this as a double, we could do that, and we could sort of just replace these two with a double right now. The only thing is that I wanted to keep the printed parts count low, and printing pulleys, I tried it before, it doesn't really work all that well. You can use PLA, but the problem with PLA, because it's for the wear resistance, the problem with PLA though is over time it starts to get all funky, and then the other thing is it cracks. So I didn't really like using printed parts. If we could get away with two pulleys here, two metal ones, like these, I just use two, and then we gotta go with that. We only need one extra on the one that interfaces to the motor anyway. So that gives you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these you need for a printer, and 8 of them are just basically linking axes together. 2 of them are for the interface to the motor. So any clearances to the motor and extruder? Oh, that's a good question. So no, it doesn't, because what's happening is at the top view here, and move this away. Basically, the rods extend past the this rod and this rod. Let me just see yeah. So if you imagine these two characters moving to the extreme, which is the end of this rod to the side of this rod, and here, and this spider moves to this corner here, it would still be clearing this motor. So same thing on this side is it just clears the motor. So yeah, those mounts were that size for a reason. They put the motors right in the spot where I could get it into the extrusion enclosure and get it as close to the wall as possible and still not interfere with the spider. So yeah, it is very close, but this doesn't interfere. And the for this, I think we will talk about this before as well. Is that um, the extruder is not going to be on the spider. The only thing that's going to be on the spider is going to be the hot end and the probe. So it's going to be some kind of Bolden setup. So we're talking about that, and one of the things that I was debating was a flying extruder. So um, that is still sort of simmering in my mind. I'm not sure how we would um, implement a flying extruder in the sort of Ultimaker style um, boot mechanics. One of the biggest problem with the flying shooter is that you have to sort of somehow hang it in space above the spider, and have the spider um, still have a bolting tool flexible enough um, to send the filament to the hot end, but short enough to you get the benefit of the flying extruder. So what there was a lot of different ways of doing it, and I think with somebody said, I think Skydriver, somebody sent me one link where they had all sorts of weird fishing line hanging in the extruder. I gotta look at that and see what we could do, but for now I think for most of what we do, going with a Bolden uh, that's coming off the top, like hard mounted for now, will work. And then we just have to get a flexible PTFE tube to get it down to the hot end. So not sure yet, but like I said, most of the ones you guys see on or for using this sort of mechanism uses a Bolden, and direct drive works, but then you kind of lose the inherent advantages of having a lighter weight spider, right? Because you put all that weight on the motor and everything on it, that's going to be really heavy. I mean, right now, let's zoom back in here. There isn't much in the spider. I mean, I have to still model the top cover and the bottom cover, but otherwise, we might extend this side a little bit so that there's a mount for the hot end. But otherwise, yeah, I mean, there's not a lot on the spider, and if we try to slap an extruder on there, it might be a little heavy. Let's see, since you guys are here and I show you guys it before already, let's see, bring a platform in here, and then you see that it's not really in the right spot right now, but like if I move it a little, let's just move it. Move. Like normally would it probably be in this spot, I think. Let me think. Yeah, right about there. I think that's where we would have ended up um, with the Z platform. So you could tell that like you kind of have the drivetrain, like the motors on top of the moving gantry, then the extruder, like that extruder hot in here, kind of bed down here. So we have a lot of, it's kind of top heavy, but you that way you could move this whole assembly up and down the columns to get more Z height. It doesn't, it's no longer tied to Z. Like your whole geometry, your XY mechanism is movable. You move this up and down the whole setup on these four poles, and it gives you the ability to get more Z height if you needed to. Guess you guys probably see it already, so I'll take it back on. One of the things we were playing around with was Cyclops. So thinking about Cyclops, I can mount it in this configuration where it's right in the middle of the spider, and I'm able to get they'll probably may move it a little bit higher depending on how the tubes are run, but that's one of the ideas is floating around is using a Cyclops. We did play around with like stick a E3D hot end in there, so E3D V6 on the corner here. Either one of those will work. The spider. This is the minimum amount of like the spider size, but we can make this bigger. But then um, we start losing the printable surface area, and we would have to make the whole gantry system larger to take into consideration the blocks are gonna like the spider is gonna prevent us from going to the corner. So right now you can tell this is still pretty. We still have to kind of make this bigger by moving this bed out a little more. So I think for the first iteration for the alpha test anyway is let's not worry about how much coverage we have on the bed. Let's kind of sort out whether or not there's clearance issues, whether there's structural issues with the way using these rods and the cross rods, whether that they hold up to what we think he's going to do, and then whether these bushings is going to work the way we think it does. And once we get all those sorted out, then we can kind of lengthen these rods to push the corners out to make sure that we get enough space, right, for this to get all to get the full use of the space on the heat bed. There was some. I think there was a question about how like there's still space between here, like this Z mount and the side of the enclosure. So what's going to happen is actually there's going to be cross. Oh, let me move that. There's going to be cross extrusion that goes behind here, and then in another extrusion that comes across here. That's going to provide the mounting points for the motor and the lead screw. Not the lead screw. The smooth rods and the lead screw is going to have space. So that's not modeled right now because we haven't gone to that yet. But the bed itself is going to be tied to the frame separately from the top gantry movement. So that's why I said like if we move this up, we basically could adjust how much space between these two mechanisms to compensate for the different sort of hot ends that we use. Okay. Any questions, concerns, suggestions? So I think in the chat I mentioned that I ordered the rods already. So the on the model here, these rods are 350, and looking at it, looks like we are pretty tight, like because we're putting that Z platform back. You can tell we are running out of space to move this, so I went with 400. 400 smooth rods just for the test. Might could need to go longer, but 400 I think is good enough for now. So when with 400 for the 10 mil rods on the outside, so that this whole corner is going to go out this way by 50 mil, and hopefully that will have enough space for this character to travel the full width, and then also because this is also 400, hopefully has enough to travel this way. So plans for the coming week, stream again on Wednesday. I think Wednesday and Saturday works a little better for me. I was able to get a lot more done, not having to deal with a stream every Tuesday or Thursday. So Wednesday stream works. So and Saturday morning I could kind of finish up some of the work. So I think Saturday and noon also work. So it's gonna stick with the Wednesday Saturday schedule. And then in between times, start working on the rest of this. I mean, his guitar is coming along pretty good. So the coming plan is going to be to get get these rod mounts designed and printed, um, so that they're ready to go. Turn off this bed again because the bed is over the way. So, and the other one is work on this one, the special one where I need to use the vertical channel. Finish that mount so that I could start ordering these extrusions and start putting it together. Actually, that's what that's meant to be. Put it together enough that I could get the pulleys to work, and then get these quad carriages moving. The spider, like set the spider top and bottom covers modeled out so that I could start moving the spider around. And once that's done, um, and I get these motors wired up, I can actually do the first movement test. So that's kind of exciting news. I can actually get this on the tabletop and start making it move and start to um, sort out any issues. Oh no, don't worry. Like basically, um, I need. It's gonna be a lot. It's gonna be a few iterations on my end before it even goes out to alpha. Um, so what's gonna happen is I probably, like I said, I got the 400 only because there's two things, right? One is, um, I could reuse the 400 on a Voron, so it's not wasted. So, like, I've been trying to, like, one of the mistakes I made going last time was kind of buying a lot of stuff and physically trying things out, and I have another set of extrusion for the Haribo 3030 that was way too short, and the hole wasn't in the right spot. So I'm kind of moving away from that sort of physical beta tests or physical alpha fitment test. So I'm using as much as I can. I'm trying to be strict about using Fusion to position things, and then using the built-in joint mechanism to to slide these carriages along to figure out that um, I'm going to get coverage on the bed, right? So, like I said, is the alpha is going to be pretty close. I think once I announce that we're going to go alpha, it's probably going to be like 90% that we're going to be close. Is this is working away on the extra 10% of fitment issues that we didn't see before, or difference in people's prints and people's parts and stuff like that. But the general dimensions of the box should be pretty close to exactly where you need to be for the print surface that we're going to go with. Also have to remember too is that depends on where you get the make plate, right? Because I paid let's say $20 for make plate. I forgot how much it was. Let's say $20. I had to pay an extra $10 on top of that to get precision cut. What precision cut means is like within 0.1 of an inch. So otherwise, it's just basically they lop it off the sheet and they give it to you. Like they don't actually work with it. And the other thing is that I'm actually going to take mine out to a machine shop to get it, like I said, perimeter and deck, so that I know it's exactly 300 by 300 and it's exactly 9 mil thick. So if you don't do that, then like I have to kind of make that variation. So you won't be able to print right to the edge. You'll probably be printing like to maybe 10 mil off to the edge, because you that way it gives you space too, right? Like you don't want to go right to the edge. So I'm mumbling on and on about this, but basically, yes. To answer your question, Donald, is once we go to alpha and the bomb's out, it's gonna be that's the size you need. You don't need to mess around with rebuilding the enclosure of the bed size. The alpha test is really saying, um, does these bushings work for this bot, and do we need to sort of play around with the tolerances of the parts, because let's say the outer diameter bushing was 10. Right now, the way I modeled them is that you get a 10.1 or 10.2 hole, because we don't know that the printer is not going to be exact right on 10. So if we make it 10, it's going to be like 9.8 or 9.9. So if I make it 10.1, 10.2, the extra extrusion is going to give you a 10 mil hole. So things like that, if we find that, you know what, maybe we're too pessimistic about the tolerances and we went too big. Like I say, instead of a 0.2, we could have gone with 0.1. Then yes, we'll adjust the STLs and stuff like that for those tolerances. But the part itself, I mean, I think, printing them out, like so, and then testing them on a test jig and stuff like that, it's pretty much going to prove out most of the parts, right? Like there's not going to be a major like showstopper issues with these, right? Um, let's see what else. What else could we go wrong? The panels. So for me is I designed it so that you guys could slide panels in there. Personally, I don't need an enclosure, so that's gonna be somebody else who has to test the enclosure, and how to buy the panels and the BOM and stuff like that for that. Um, but the like like I'm making it I'm making the commitment to leave those channels open for, like I said, these channels open here for the enclosure. So um, shouldn't be that bad to just use those channels to slide in your panel. So um, yeah, that's that. Kind of leave it at that. Yeah, like I said, by the time it gets to the alpha, it's going to be pretty close. And then I think also part of the alpha is going to be testing out things like the smoother wear configuration. So yes, we are going with smoother wear. If you want to use Duet, you could do that. That might be a separate fork or separate effort. But the official reference build is going to go with a smoother wear board, dual extrusion capable board. What it like, and then that's the other thing is that the alpha is going to basically decide between dual and single. For me, is like if I could get a easy to use dual, yes, I'll do it. But I'm not going with two hot ends. Like that's given right now. I'm not going to go with two hot ends. If you want to, okay, I'll get to you inside driver in a second. So what I'm trying to say is I'm not gonna go with two hot ends. Um, Best case is going with like the I think it's the Chimera that has two hot ends in like two nozzles in the same hot end. Maybe, I'm not sure, but definitely not two E3Ds. I mean, you could see go back and look at all the other people who have done it with two hot ends. It's a nightmare. You would never get the two hot ends in the same level. If you think right now you have issues with the Pinda and the one E3D, think 10 times or 100 times worse with two E3Ds and one proximity sensor that you have to reference off of. It's way too many variables. I'm not going to go there. If you want to take the effort, that's fine. But for me, it's like it's not worth the trouble. So it has to be something that is easy to use, right? So is it Chimera? I think it's Chimera. Yeah. So probably going to go with Chimera because that one is the easy way, I guess, to do it. And like if if somebody wants to kind of spin it off and do other mounts, great. You know what? Like the mechanism's there. So yeah, we were talking about the Cyclops too. So I think for myself, I'm gonna use the Cyclops mainly because that gives me sort of pseudo dual extrusion with only one nozzle to deal with, and I'm not having to deal with like nozzle offsets and all the other nice stuff that goes with it. Again, like that's probably 4 or 5 stages from now. I mean, right now, like I said, the first stage is to get this whole mechanism mounted to a actual test frame so that you know people like Pat who got voluntold to look at smoothware, they could start playing around with smoothware and make this actually move on its own power, and then start thinking to start like to tune things like how many turns of the pulley to get it to go 1 millimeter or 10 millimeter, to make sure that the steps are correct, and then start thinking about um, how we're gonna mount the end stops, because that's the other thing, is that there's no end stops right now. So we need to figure out, so there's two ways to do it, right? Either the easy way is to mount the end stops on the spider, so when it hits because that's what I designed it, is to be smooth on this side, is that when the spider hits the edge of the Y characters, it triggers off the end stops. Then basically you have a bundle of wires that come off the end stops, a lot cleaner. If we put it so that the end stop is triggered somehow on these rods, is a lot trickier, because you can't mount it on these rods. You can't move because normally in a Cartesian system you would mount them on the smooth rods, so that when the carriage moves against that end stop, it would trigger. The problem is this rod that we would normally mount it to spins. You can't mount a end stop to this rod, and because your pulley's in the way, you can't mount the end stop on the end of this rod either. So your other choice is somehow float a end stop here and then put a arm bar that comes out of here that triggers it. Some of the guys have put a flag and a mount that comes off of here to trigger off the optical sensor. Again, that is something that we have to think about, but for now, like it's on the list of things to talk about, but right now it's not a concern. I know, Steve, I know it's more wires off of the spider, but you gotta remember, if we're going with a Bowden with no motor on the spider, that's four extra wires that you would have used for the motor, but now using for two end stops. So same thing. You're not getting more wires. You are getting the same amount of wires coming off of the the spider. So right now, if let's say let's make the assumption we're going with a Bowden setup. You have two wires for the one end stop, two wires for the other end stop, two wires for the thermistor. Okay, so that's 6 low voltage wires. So in theory, you could probably go with a Cat 6 or like the like some kind of low voltage wire. Then the hot end, you only get the 2 pairs of hot end wires. So the bundles are gonna be a lot smaller. So I think it'd be fine. And what's happening too is that it would come straight down. So there's no and you loop it. So basically the fatigue is not there, because you would have a kind of like a support column for it to tie the wires to. What keeps the characters from moving outwards since the rods are not secure with a set screw? That is a good question. That too. So like Patrick is saying that we could probably use one ground for all of them. Again, that's wiring and electronics. We could kind of deal with those later. I'm just trying to think about what Roger is asking about. That's a good question. I haven't never really thought about that. I have to see how the other guys do it, because it seems to be just held in place, like it's just there. Because I don't see them using a set screw. I have to look into that. I'll put that down as a question, Roger. Thanks for asking that. I guess because if you had a they, let's see, we had, this one's really tight. They don't move out because the on this side. Okay, so let me take this side off. You see on this side, it comes out flush to here, and it touches the back here where it's actually sort of acts as a backstop, so it just doesn't go all the way through. And it would be the same thing on this side where, if I get this oriented correctly. It would be the guess you can, like, it would be the same thing on both sides. So that rod's not going anywhere. Once it's in the groove, it's not going anywhere. So does that answer that question? Like the rods are not physically blocked from coming out the other end on both sides, because the way, like, the rod comes through here and gets stopped by this block. So does that answer that question? I think it does. So if not, let me know, and I'll try to figure out what you're asking, because I think it's just in there by force. Like, it's not, there's no space for it to move once, like I could push this as hard as I can on here, it won't go anywhere because it's being held in place. So what keeps them from going too far? Well, okay, so pushing actually stopping characters from moving because there's no movement. See you later, Steve. Well, okay, so there's two questions there, right? One is if he's asking, well, how he keeps it from going too far. Well, this pulley here is going to be secured by two set screws, and this carriage will physically get stopped from right here. So that keeps it from going too far. And if that doesn't stop it, this spider will hit the carriage on this end. So we have to play around with the end stops, but normally something on the spider end will trigger off the end stop from touch, so that it shouldn't touch the carriages. So if that's the question, then that's the answer, is that the end stop should stop it from touching the so there's a couple of ways to do it. The other thing is that I've seen is the kind of fancy is we put a magnet here, and we put a hall sensor on this side and the hall sensor on this side. Well, you know, what to cover, and then basically once it starts to approach the magnet, it knows that it's too close, so it will stop. So it's actually a no-touch end stop. So we could do that as well. So that stops it from moving, from the spider hitting the carriages. It doesn't stop, and then by the virtue of the spider not hitting the carriages, then the carriages can't move to the edge. So that's kind of a, I know it sounds like a cop-out answer, but that's pretty much it, is that, hey, so I know it sounds like a cop-out answer, but if I prevent, because this is a two-way relationship, right? The spider and the carriage to the spider is a two-way relationship because it's held together by these two rods. So if I tell you that you can't, this is the furthest you go because this carriage is being stopped from hitting this edge because the hall sensor on this side or the end stop sensor on this side is not letting this guy move forward. This is going to be the final position of the spider. The reverse is true. If this carriage is not allowed to move forward from this orientation, this spider, by being held back by this rod, is not going to hit this rod carriage. So it's physically, if the end stops are set up quickly, it's physically impossible for the spider to hit the characters. And the first time I seen it, it was like, because um, you don't see the end stops, it makes it hard to understand. But once you start going there, you see, like, I think what it was that there was a way to make the optical sensor work here. So let me just kind of play with that next few weeks and see what I come up with. Link the belt over the square. Well, the belt help, but mostly it's held by this rod and this rod, because this rod holds it in this plane, and this rod prevents it from rotating. So um, I kind of took the cover off to show off this belt tensioner, but if you imagine, there's about there's about 4 millimeter or 5 millimeter worth of rod inside a 8 millimeter hole that is being held. So unless there's enough force for it to crack this hole open, this is being held at 90 degrees to this wide carriage, and this one is holding this carriage up. So the belts will also help it align so it doesn't flop back and forth, but it's not the main structural point. The main structural point is this rod and this rod here. Overall, I think, like I said, it's kind of complicated to model and explain. So one thing that once I get these guys, like the rest of these guys, like the rod mounts and everything, once I get it working, I will make this a complete frame so that I can start to animate it. And once I start animating it, you guys will see what I mean. Is that I will limit I'll limit the movement of this spider on these two rods. Then you see that if I somehow electronically limit the movement by using end stops or hall sensor or something like that, it will prevent it from hitting the corresponding XY character. So I think that's worthwhile, since there seems to be a little bit of questioning the mechanism. I think it will be worthwhile once I get the next 2-3 parts modeled out, is to actually make an updated current view of how the mechanism works, and then have it so that it starts to be animated, so you can see where things are going. And then if everybody's on the same page, then we can move on with the spider. First thing I was thinking is that we could make a spider that holds a pen, and we could make this into a XY plotter and have it test the movement of have it test the movement of the mechanism, so that we could test with the smoother wear and like get it out of the way. Chris, the outside rods are like these guys are 10 mil rods. The inside ones are 8 mil. The 8 mil rods probably going to be about 350, and these outside ones going to be 400 length. On the OT Maker, the outside rods are 8 mil, the inside rods are 5 mil. So we kind of went up one size with both rods, because I'm also going with 400 for this, so that the whole mechanism is inside an enclosure. So slightly different, still a slightly different implementation of the same idea, like the cross rod with the spider, using thicker rods. The move to take 10 and 8 mil rods is a little bit more work, because normally if you build an Ultimaker clone, you would just buy the clone carriages and the clone spider. You only have to work out the rod placement, the rod mounts, and stuff like that. Going with 10 mil rod and 8 mil rod here is proving to be a challenge, actually. So a challenge in a good way. I mean, like I think in the last 3 weeks, we've got pretty far in the last 3 weeks of getting all this stuff laid out. So, and with that, we're coming up to an hour. I sort of just wanted to keep it an hour. I think 1 hour works. Yeah, I'll take up any questions and concerns and things like that. So 350 on 8 millimeter is pretty much the limit. I mean, like um, any more than that, you start getting sagging in the middle. So um, that's why like the if we want to go with 300 by 300 bed, and 350 on the 8 mil rod to get that is what do you call it? Is at the limit. 350 is the limit. I think if we want to go higher, you gotta start going into like some ridiculous territory where you can use 12 mil rods on the outside and 10 mil rods on the inside. And I don't know if you guys seen 12 mil rods. Those things are ridiculous. I mean, you look at like that's a 10 mil pulley, and what's the comparison? Um, like the where's my 8 mil rod? That's an 8 mil rod, and yeah, is oh, oh that was kind of funny. Yeah, that is getting ridiculous, right? That's 8 mil rod. When you think about it, 8 mil rod. You talk about 8 mil rod. You can't bend it, but at 350, it has notable sag because of the weight of the rod itself that will dinged it. Um, so yeah, 300. I think for the it's 300 on the bed should be the limit. I mean, if you need more than that, you're not going to build it yourself. I mean, it's kind of getting ridiculous how some people want like a 500 by 500 now. The other day I got a request for 1 millimeter cube. And I'm like, what are you printing with a 1 millimeter cube printer? You know how big that is? That's ridiculously big, right? Skydiver. I'll get back to you on chat. I think you were asking me about the stickers. Yeah, I would love those stickers because like I'll put them up around, and I'll get back to you on it. I can't scroll back up on the chat right now, so I'll get back to you on it. And I think we have to talk about the clone beds too. Oh yeah, give me a second. Let me go grab one. So I was able to get these the other day, and got the wires. I got the wires soldered on there, ready to go. Silicone wire, so nice and flexible. I have to put PI, just brand new. Uh, no, no PI on it, but I gotta try this out. It's so flat, and it's pretty nice. So I'm happy with that. Um, not really, not really advertisement, but it is something that we're working on because one of the things that we were having a lot of problem with was getting the like sourcing the bed, right? That's like the the reason why we got the upgrade kit before. There's three things, right? One was the MK42 heat bed. Second was the Pinder, and then the third thing was sort of the fact that we get the nice set of motors, right? But the um, right now, like we have found the source for the motors. We got the beds cloned, so now the performance of the bed is amazing on it. Like the testing we've done so far on it has been great. Just got I just gotta flip them onto my printers for some longer term testing. For when I'm streaming, I sometimes I print, but sometimes I don't. But most of the time, it's printing all the time. So I'm gonna be the sort of the long term tester, is making sure that everything works the way it should. But so far in the sort of short to medium term testing, it's been pretty good. So I'm happy with that. the only thing left that we need to sort of be self-sourced is the pinder. So once we get the pinder, then we'll be totally self-sourced. And for the Haribo, we can actually make those without buying the kit, because the kit is now right now some outrageous price, like $350. So I think he whatever reason, his choice, is his company, but he jacked the price to 350, and that sort of pushes the price of the Haribo higher than if you went with a kit, right? So I think I don't think it's a coincidence. I can tell you that, because what like I've been saying all along is the price of the Haribo, if you use the upgrade kit, came out to $699 ish. So same price as a stock MK2, but you get way better performance. By jacking it up another $150, he's basically pricing the Haribo out of the market, right? Like you no longer have a comparable. Like if let's say instead of $699, now you're at 850. So you're at 850, and at 850 is the Haribo. If you bought the kit, which is not the way I recommend right now, if you bought the kit, the upgrade kit to do that, you're at 850. You might as well just go with the MK2, because it doesn't make sense. If you go with the MK2 and you pay the 150, $200 for the Masumi order and all the other stuff that you need, you still have the same. You still have the same, right? Like you get it, and you get extra stuff too. So it's kind of like, yeah, I don't care what he says about the reasoning behind that whole price increase. It was to put this whole Haribo movement behind a few laps, right? So not really gonna hold a grudge on it. I mean, that's his prerogative to, he sells thousands of printers, and he's worried about 100 or so that we're gonna be building. So not gonna go there with that argument. You guys seen how much he spent on that new warehouse and stuff. It's not like he's hurting for money. So um, anyway, that's my personal opinion, and I'm happy with what I got out of the whole amount of work that we've done on the Haribo. I think we're moving forward with the Haribo Cube. It'll be totally self-sourced, and I'm making it so that you guys could find the parts easier. I will try to standardize on one set of screws and one set of like bushings and stuff like that, or at least maybe two. I'm not gonna make like a really long bomb so that you guys don't have to go and source everything separately. And I think with the sort of virtual assembly, you could see where the bolts go, and you can see how things work. Um, we could minimize the confusion, because that was one of the things too, was there was a lot of there was not lack of documentation on how to put it together, the Haribo 3030. Even though it was self-explanatory, there's still some spots that you kind of have to watch out for. So things like that, we will try to catch those as we built this printer. Um, yeah, so I think that's the update. Like I said, it's way past the 1 hour mark, and I don't really want to drag on too much. I will see you guys in chat, and if you have any questions, feel free to reach out to me, not just about the cube, but about anything in general, about the 3030, Haribo 3030, and if there's any topics you want to cover, and any questions and concerns and suggestions, I welcome those. Best way to find me is on the Mattermost chat. It's going to be in the description, so see you guys.